Hello everyone. Once again welcome to MPLS series. Guys, in this video of MPLS, I am going to discuss inter-autonomous MPLS VPN. We have a famous concept in MPLS called inter-autonomous MPLS VPN, and we can solve it with some option. For example, option A, option B, option AB, and option C. These are the different method for inter autonomous MPLS VPN, and today we are going to discuss option A, and in upcoming day we will understand other option like option B, option AB, and option C. So later on you can compare option A to option B or to AB or to option C. First of all, we will understand what is the meaning of inter-autonomous MPLS VPN, and then we will see the configuration. So in this video I am going to talk about inter autonomous MPLS VPN by using option A method. Guys, in all previous video we had only one ISP. If I will talk about all previous video, so we had only one ISP. Let's say one customer is connected with two side. One customer have two side, had two side, and both side had connected with same ISP. Right? We had only one ISP in all previous video. But if I will talk about this scenario, so as you can see here we have two ISP 1 and ISP 2. We have two ISP 1 is connected with customer A side 1 and customer B side 1, and ISP 2 is connected with customer A side 2 and customer B side 2. Okay, means side 1 of customer A is connected with different ISP, and side 2 of customer A is connected with different ISP. In the same way, side 1 of customer B is connected with different ISP 1, and side 2 of customer B is connected with different ISP, that is ISP 2. So in this scenario we will have cooperation between ISP 1 and ISP 2. What I am saying, we will have cooperation between ISP 1 and ISP 2, because ISP 1 and ISP 2 are going to work together in this scenario, right? And between ISP 1 and ISP 2, like router 4 and router 5, we will configure normal BGP. We will have only IPv4 service here between ISP 1 and ISP 2, and like between router 4 and side 1 of customer A we will have one VPN. Okay, and side 1 of customer B and router 4 we will have one VPN. First of all, let me discuss let me give you some overview of this scenario, then we will discuss anything and configuration part. Okay, so as you can see in this scenario, we are going to create VPN here. Actually, for customer A side 1 we need to configure VRF over here, and we will configure MPBGP. So router 2 is my route reflector in ISP 1, and router 6 is route reflector in ISP 2. You already know how to configure route reflector and what is the concept of route reflector. We are not going to discuss route reflector concept here. Okay, but in ISP 1 router 2 is route reflector, in ISP 2 router 6 is route reflector, right? So router 1 will have one neighborship BGP MPBGP neighborship to router number 2, and router 2 will have one MPBGP neighborship with router number 4. So we will have one VPN over here between router 1 and router 4, MPLS VPN for VRF A. That VPN will carry traffic of VRF A as well as traffic of VRF B. In the same way, here like router number 8 is connected with two customer, so here we will have one VPN, right, through route reflector through router number 6, and this VPN will carry traffic of VPN v4 prefixes of customer A and customer B. Okay, and then we need to exchange these two prefixes between router 4 and router number 5. So finally, actually what we need one VPN between router 1 to router number 8. So we are going to configure MPLS VPN between two autonomous system. We are going to configure MPLS VPN between two autonomous system. Here autonomous system is 65,000. Here autonomous system is 65,101. So that's why we are saying it inter autonomous MPLS VPN. Configuring MPLS VPN between two or more autonomous system is called inter autonomous MPLS VPN. Getting my point what I am saying? Configuring MPLS VPN between two or more autonomous system is called inter autonomous MPLS VPN. First of all, let me show you here in the notepad what will happen. From our previous learning, from the previous video, we understand that between router 1 and router 4 we will have one VPN. Here we will have one VPN between router 1 and router 4, MPLS VPN, and between router 5 and router 8 we are going to configure one VPN. Soon you will see we will configure one VPN between router 5 and router number 8 through router reflector. Fine. After that, what will happen when router number 9, see this is router number 9, router 9, R9, R9 will advertise one network, this network 192.168.1.0/24. It will advertise IPv4 prefix, right, to router number 1, because here we will have BGP neighborship between router 1 and router number 9 we will have BGP neighborship. So with the help of that BGP neighborship, router 1 is going to advertise this network to router number 1. This is IPv4 prefix. This is IPv4 prefix. Okay, what router 1 will do? Router 1 will receive this prefix R1. R1 will receive this prefix, and router 10 will also advertise one network to router number. Router 10 will also advertise one network to R10 to router number 1, that is 172.16.1.0/24. Both are advertising IPv4 prefix to router number 1, right? Now what router number 1 will do? Router 1 will advertise this network information. First of all, router will inject this network in VRF, let's say A1 or A2. Here let's say we have VRF A1 for customer A side 1 and VRF B1 for side 1 of customer B. Okay, so it will, router 1 will inject this prefix in VRF routing table, and it will inject VPN v4 prefixes. And after that router 1 will advertise that VPN v4 prefix to their neighbor, to means to router number 4, to router number 2, and router 2 will advertise it to router number 4. So finally router 4 will get one VPN v4 prefix, two VPN v4 prefix. One is 190, sorry, let's say here I am using for VRF A1 I am using RD value 1:1. So 1:1 ratio 192.168.1.0/24. This is VPN v4 prefix. Router 1 will advertise it to router number 4. This is R4, let's say R4, right? In the same way it will advertise one VPN v4 prefix, one more VPN v4 prefix, that is, let's say we are using RD value 2:2 for customer 2. 2:2 ratio 172.16.1.0/24. R4 will receive these two VPN v4 prefix from their neighbor from router number 1. These are VPN v4 prefixes, right? Again R4 is going to advertise these prefix in the form of IPv4. It will advertise IPv4 prefix to R5, which prefix? One is this one, 192.168.1.0/24, and another one is 192.172.16.1.0/24, right? It will, router 4 will advertise IPv4, normal IPv4 prefix to router number 5, and again on router number 5 we will have VRF, and router 5 will convert this IPv4 prefix into VPN v4 prefix, like router 1 have converted IPv4 prefix to VPN v4 prefix. Okay, and router 4 will have this network 192.168.1.0/24 and this network 172.16.1.0/24, and there will be RT value as well, route target value, with both VPN v4 prefixes. So let's say here RT value is, let's say here RT value over here is 100 ratio 100 ratio 100, and this is RT value, route target value, and here RT value is 200 ratio 200. Let's say with this prefix RT value is, let's say, 200 ratio 200. So if router 5 when router 5 will receive IPv4 prefix, router 5 will convert it into VPN v4 prefixes, and after that it is going to advertise to their neighbor. To their neighbor means to router number 8. To router number 8. Which prefix? This prefix, VPN v4 prefix, 191 ratio 1. Here whatever RT value you have defined, let's say here also we have defined same RT value, 1 ratio 1. So it will, VPN v4 prefix will be this one, 192.168.1.0/24. This is VPN v4 prefix, and here we will have one more VPN v4 prefix, 2 ratio 2 and 172.16.1.0/24. right? Here if we are using different RT value for VRF, then definitely RT value will be different over here, right? Because route distinguisher value is used to differentiate the prefixes in the in the global. So that's why we are using RD value. So if RD value is different over here, so in VPN v4 prefixes you will see different RT value. But let's say we are using same on router number 1 as well as on router number 5, so here also we are able to see same RT value. After that R8 is going to, here there will be route target value. So let's say route target value over here is route target value is again 100 ratio 100, and here route target value is, let's say 200 ratio 200, 200 ratio 200, and router 1 will import 100 ratio 100 for VRF, let's say A2, and 200 ratio 200 for VRF B2. Here we have two VRF A2 and B2. Okay, so what router 8 will do? Router 8 will again convert this VPN v4 prefix to IPv4 prefix, and after that it will advertise to router number 11, right? And this prefix, it will again convert this prefix to IPv4 prefix and advertise it to router number 12, right? In the same way, when router 8 will advertise this network side 2 of customer A to router number 5, router 5 will advertise those network. First it will, router 5 will convert VPN v4 prefix into IPv4, and after that it will advertise to router number 4, and again router 4 will convert IPv4 prefix to VPN v4 prefix. After that it will advertise to router number 1. I am going to show you the configuration, right? Don't worry, but for now just try to understand one thing, that between ISP1 and ISP2 we are not going to create MPLS-VPN. Here we will have simple BGP, normal BGP between router 4 and router number 5. Here we will exchange IPv4 prefix, not VPN v4 prefix, between ISP1 and ISP2. You will see how we will configure it, okay? And rest configuration, like configuration in service provide ISP1, or VRF configuration on router number 1, or VRF configuration on router number 8. See, we need to configure VRF on router number 1 also, on router number 4 also, 5 also, 8 also. So rest VRF configuration like route target, RD value, or BGP, OSPF, those configuration is same. And one more thing here, you can see in ISP1 we are using OSPF as a IGP protocol, and in ISP2 we are using ISIS protocol as a IGP protocol. So IGP protocol in ISP2 is ISIS, and IGP protocol in ISP1 is OSPF. Okay guys, now I am going to show you the configuration part. Let me take you here, and here in the notepad you can see the configuration. First of all, let me discuss the configuration of router 1. This router, see on router number 1, first of all I will configure host name, that is fine. Then as you know, we need to enable MPLS on WAN interfaces, so we will configure MPLS label range. So MPLS label range over here is 100 to 199. After that, fast Ethernet 0/0, say no shut, and IP address. On fast Ethernet 0/0 means between router 1 and router 3 I am using 13 network, 13.1.1.1 network, so IP address is 13.1.1.1 255.255.255.0. after that I am enabling OSPF on this interface, IP OSPF 1 area 0 and IP OSPF network point to point. I have changed the network type for the faster convergence between router 1 and router 3 on the broadcast link. After that, this interface fast Ethernet 1/0, fast Ethernet 1/0 is connected with router number 2. Here also no shut, and then IP address is 12.1.1.1. Between router 1 and router 2 I am using 2L network, and this is the subnet mask. After that we have enabled OSPF over here on this particular interface, and then we have changed the OSPF network type. Then we need one loopback here, so interface loopback 1, IP address is 1.1.1.1, subnet mask 255.255.255.255, and on loopback interface also we have enabled OSPF. Okay, after that I am going to enable MPLS, so you can see router OSPF 1 and router ID 1.1.1 and MPLS LDP auto config. So this command will enable MPLS on all OSPF enabled interface. After that we need to create VRF, 2 VRF, because we have 2 customer over here. 2 customer is connected with PE router of service pro ISP1, and so that's why we will create 2 VRF. IP VRF A1. Here for VRF A1 for customer A I am using RD value 1:1 and route target value both 100:100. It is importing as well as exporting 100:100. So this is for customer 1 side 1, and IP VRF B1, this is for the customer B. For customer B I will create VRF B1, and for customer B I am going to define RT value 2:2 and route target value both 200:200, similar like previous video. After that, VRF assignment, as you can see, fast Ethernet 2/0, fast Ethernet 2/0 is connected with router number 9. So this interface is member of VRF A1. A1 is VRF for customer A, and then IP address between router 1 and router 9 I am using 19 network, so 19.1.1.1 255.255.255.0. guys, this is first video of inter-autonomous MPLS VPN. That's why I am discussing everything from the scratch. We are discussing IP addressing as well. Okay, after that no shutdown. Then interface fast Ethernet 3/0, so IP VRF forwarding B1, this interface 3/0 is connected with router number 10, and between router 1 and router 10 I am using network 10. 10.1.1.1 is the IP address over here. This is the subnet mask, no shut. And after that, finally, as you know, we will configure BGP. So router BGP 65,000, and then no BGP default IPv4 unicast. We have disabled the BGP for IPv4 unicasting, and then neighbor 2.2.2 remote AS 65,000 like router number 2. As you know, router 2 is my route reflector, so we will form BGP neighborship between router 1 and router 2. So on router number 2 also we will create one loopback 2.2.2.2. so here you can see neighbor 2.2.2 remote AS 65,000 neighbor 2.2.2 update source loopback 1, and address family VPN v4 neighbor 2.2.2 activate. Then we are going to configure BGP for VRF, as you know. So address family IPv4 unicast VRF A1, address family IPv4 VRF unicast VRF A1, and I am going to say neighbor 19.1.1.9. This is the IP address of router number 9. So 19.1.1.9, and remote AS is 100. Customer A is using AS number 100, customer B is using AS number 200. Okay, so remote AS is 100, and then neighbor 19.1.1.1 AS override, as you know, or you can run AS allow on router number 9. After that, address family IPv4 unicast VRF B1 BGP for VRF B1, and here I am going to say neighbor 10.1.1.10, and remote AS is 200. As I told you that customer B is using remote AS 200, and neighbor 10.1.1.10 AS override. This is simple configuration of router number 1. Let me copy the configuration of router 1 and paste. Let me paste this configuration on R1 router 1, and here is the console of router number 1. Let me paste this configuration, config T, and see. So we don't have error, we don't have any error. That means all command is correct. We have configure the VRF, we have configured the OSPF. So IP OSPF interface brief, you can see OSPF is enabled on loopback 1, fast ethernet 1/0, fast ethernet 0/0. So MPLS interfaces, so MPLS is also enabled on fast ethernet 0/0 and fast ethernet 1/0. And so IP VRF, so we have two VRF, VRF A1 and B1. RD value for VRF A1 is 1:1, RD value for VRF B1 is 2:2, and these are this is the interface. Fast Ethernet 2/0 is the member of VRF A1, and Fast Ethernet 3/0 is member of B1. Okay, now in the same way I am going to configure router number 2. So see the configuration of router 2. First of all, host name, then MPLS label range is 200 to 299, then interface fast ethernet 0/0, IP address is 12.1.1.2. Okay, so this is the IP configuration. You can use any IP address, and then we have enabled the OSPF on that interface. After that, IP OSPF network point to point interface fast ethernet 1/0. Here also we have configured the IP address 24.1.1.2, and IPOSPF 1, IPOSPF network point to point. We have created one loopback. On that loopback, IP address is 2.2.2.2. After that, router OSPF 1, router ID 2.2.2, and MPLS LDP auto config. Right. So we have enabled MPLS, we have enabled OSPF, we have configured the IP addresses. Now lastly we need to configure BGP. So here router BGP 65,000, as you know, ISP1 is using 65,000 AS. After that, no BGP default IPv4 unicast. Then neighbor 1.1.1 remote AS 65,000, neighbor 1.1.1 update source loopback 1, and there is one more neighbor like router number 4. Router 1 and router 4 is the neighbor of router number 2. Okay, so neighbor 4.4.4 on router number 4 also you will see we will create one loopback. Okay, 4.4.4 remote AS 65,000 and neighbor 4.4.4 update source loopback 1. And after that, address family VPN v4, neighbor 1.1.1 activate, neighbor 4.4.4 activate, neighbor 1.1.1 route reflector client, neighbor 4.4.4 route reflector client. Okay, so let me copy this part of configuration here, router 2, and let me paste this configuration on router number 2. Enable config T and paste. After running these commands, I am expecting OSPF neighbor ship between router 1 and router 2. We are expecting LDP neighborship between router 1 and router 2. We are expecting BGP neighborship between router 1 and router 2. And let me verify it. Here you can see LDP neighborship. Okay, and we can verify it. So IP OSPF neighbor, first of all OSPF neighborship will come up. You can see neighbor 1.1.1, then so MPLS LDP neighbor, so 1.1.1 is the neighbor, and so BGP VPN v4 unicast all summary. So BGP neighborship is idle. Wait for some time, let me check. Okay, with 4.4.4 BGP neighborship is idle, and for 1.1.1.1 neighborship is fine. Okay, so receive prefix is 0. Okay, done. Now next router configuration is router number 3. On router number 3 we don't need to configure BGP. As you know, we will configure IP address and OSPF only. So host name R3, MPLS label range 300 to 399. This is configuration of R3. And on fast Ethernet 0/0 IP address is 13.1.1.3, IP OSPF 1, IP OSPF network point to point, fast Ethernet 1/0, IP address is 34.1.1.3, and IP OSPF 1 area 0, IP OSPF network point to point, and a router OSPF 1, router ID 3.3.3, and MPLS LDP auto config. Now I am going to copy this part of configuration and let me paste this configuration on router number 3. Done. Now finally we need to configure router number 4, the last router in ISP 1. So on router number 4, guys, try to understand the configuration of router 4 carefully. See, first of all, we have defined the MPLS label range, then IP configuration like interface fast Ethernet 0/0, interface fast Ethernet 0/0, IP address is 34.1.1.4, and okay, subnet mask IP OSPF 1 area 0, IP OSPF network point to point, interface fast Ethernet 1/0, which is connected with router number 2, IP address is 24.1.1.4. This is subnet mask IP OSPF 1 and IP OSPF network point to point. Then we have created the loopback 4.4.4 and we have enabled the OSPF1 loopback interface. After that, we have configured the LDP, router OSPF1, router ID 4.4.4, MPLS LDP auto config. Then here on router number 4, again we are going to configure VRF, right? See, as I told you that you have to cooperate between ISP1 and ISP2, right? So ISP1 have to create two VRF, because this is, you know, this is option A method, right? The method which we are using over here is option A. In this method, we called option A to back VRF. Why back to back VRF? Because here we are going to configure VRF, here also we will configure VRF, and between VRF we will configure BGP. Between this VRF and this VRF we will configure BGP. So that's why we called it back to back VRF. So what I am going to do, see, I have two VRF over here, VRF A1 and VRF B1, but we have only one physical link, right? So this is disadvantage also, guys, of option A, because you know here we need to create two sub interface, one for VRF A1 and one for VRF B1. We need to create two sub interface, one for VRF A1 and one for VRF B1. So maybe one interface will be 2/0.1 and 2/0.2. Okay, so let's say if we have 1000 number of customer connected with router number 1 or with ISP1, or 1000 number of customer is connected with ISP2, so we need to create 1000 number of sub interface on router number 4 and on router number 5. So in upcoming day when we will discuss next option like option B or option AB and option C, you can compare each with each other, right? Each method which with each other. But here let's say in back to back VRF we are going to configure sub interface. So first of all on router number 4 we will create two VRF like VRF A1, or you can configure VRF with different name as well. And here also I am defining RD value 1:1 and route target value both 100:100, right? Same like router number 1. And after that IP VRF B1 and RD value 2:2, and route target value is again same 200:200. Okay, after that fast Ethernet 2/0, which is connected with router number 5. Only you need to run no shut command on this interface. On fast Ethernet 2/0 you will run no shut command only. Then we will create two sub interface. One is fast Ethernet 2/0.1. Here let's say I have defined that this interface is member of VRF A1 and encapsulation protocol .1Q for VLAN 1, let's say, and then IP address. we can define same IP address on both sub interface. So that's why you can see I'm using same IP address on this interface also and on this interface also. Okay, so interface fast Ethernet 2/0.1 IP VRF A1 encapsulation .1Q for VLAN 1, and IP address is 45.1.1.4. Between router 4 and router 5 I am using 45 network. IP address is 45.1.1.4. And then interface fast Ethernet 2/0.2 IP VRF B1 and encapsulation .1Q for VLAN, let's say 2, and here we can configure native as well. And then IP address, same IP address I am configuring over here also on this interface. And then finally we are going to configure BGP on router number 4. Router BGP 65,000 and router BGP 65,000, and then no BGP default IPv4 unicast, neighbor 2.2.2 remote AS 65,000, neighbor 2.2.2 update source loopback 1, and address family VPN v4 neighbor 2.2.2 activate. Guys, now we are not going to configure BGP between router 4 and router 5. Later on we will configure BGP between router 4 and router 5. First understand the configuration of ISP1. Okay, so we have configured the BGP neighborship between router 4 and router 2 only. Now let me copy the part of this configuration of router number 4, and let me paste it on R4. After running these all command on router number 4, again I am expecting OSPF neighborship with router 2 and router 3. I am expecting LDP neighborship with router 2 and router 3, and I am expecting BGP neighborship with router number 2. Okay, and let me verify it. So IP OSPF neighbor. So you can see OSPF neighbor 2.2.2 is neighbor and 3.3.3 is neighbor. After that, so MPLS LDP neighbor. So you can see 2.2.2 is the neighbor and 34.1.1.3 is the neighbor, means router number 3. Okay, and so BGP VPN v4 unicast all summary. So 2.2.2 is neighbor. Okay, so till now we have configured the ISP1 network. Now I am going to configure customer routers like router number 9 and router number 10, because let me first configure this part and then we will move to this part. Okay guys, okay. So this is configuration of router number 9. As you know, here this is the IP configuration on fast Ethernet 0/0, and then we have one loopback. On loopback I am running this IP address 192.168.1.1, and then router BGP 100. As I told you, here we are running BGP 100 and neighbor 19.1.1.9, remote AS 65,000, and then I am advertising this network in BGP. This is similar configuration, like we had discussed this configuration, customer is router configuration, lots of time in previous video. So let me take you to R9. On R9 let me paste this configuration, and after running this command I am expecting BGP neighborship between router 1 and router 9. So just wait for some time. Yes, you can see the BGP neighborship, and so IP BGP in BGP table it have added this network, so it will advertise this network to their neighbor. Who is their neighbor? Router number 1, and router 1 will have now this network. Let me verify it. Here also you can see the log message, and so BGP VPN v4 unicast all. So yes, it have received this network in BGP table of VRF A1, and so IP route VRF A1. You can see in the routing table also it have received one network. Okay, and this is VPN v4 prefix. This is now VPN v4 prefix router. This is IPv4 prefix, but when router 1 will advertise this network to router number 4, it will advertise it. It will convert this prefix to VPN v4 prefix, like so. BGP VPN v4 unicast all and 192.168.1.0 255.255.255.0. You can see here, this is VPN v4 prefix. This prefix, it is going to advertise this prefix to router number to their neighbor, to router number 2. Okay, in the same way, now I am going to configure another customer A's router, like router number 10. So this is configuration of router 10, host name router 10, and IP address is on fast Ethernet 0/0 is 10.1.1.10, and loopback interface IP address is 172.16.1.1. right here I am using this network 172.16.1.0 for customer B. Okay, after that router BGP 200 and neighbor 10.1.1.1, remote AS 65,000, and then we have advertised this network in BGP. Let me copy the configuration of router number 10 and let me paste this configuration on R10. Okay, here also I am expecting one BGP neighborship. Wait. Yes, now you can see, no, this is different. So IP, yes, BGP. We have BGP neighborship and it have installed this prefix in their BGP table. Now on router number 1, you can check so IP, so BGP VPN v4 unicast all. You can see router 1 have installed this network in the BGP table of VRF A1 and this network in BGP table of VRF B1. Okay, and then it will advertise to their neighbor to router number 2. Let me verify it on router number 2. So BGP VPN v4 unicast all. So here also we have these two prefix, right? Now router 2 will advertise it to router number 4. Let me check router 4. So BGP VPN v4 unicast all. So yes, router 4 have also received this network in VRF A1 and this network in VRF A2 B1. So IP route VRF A1 you can see this network 192.168.1.0 and VRF B1 we can see this network 172.16.1.0. right, now I am going to configure ISP2. Okay, so till now router 4 have the prefix of customer A and customer B, side 1, prefix of side 1 of customer A and side 1 of customer B. Okay, now let me configure ISP2. Guys, configuration is same. First of all, I am going to configure router number 8. On router number 8, host name is R8, then MPLS label range is 800 to 899, then fast Ethernet 0/0. This is the IP configuration 78.1.1.8. Between router 7 and router 8, I am using 78 network. After that, here as you know, I am running ISIS protocol in ISP2. So IP router ISIS, right? This is the command to enable ISIS. If you are not good enough in ISIS routing protocol, so you can configure OSPF as well in ISP2 also. Okay, after that ISIS network point to point exit interface fast Ethernet 1/0. 1/0 is connected with router number 6. So between router 6 and router 8, I am using 68 network. So IP address is 68.1.1.8. Subnet mask is 255.255.255.0. IP router ISIS network point to point, and then we need one loopback. So interface loopback 1, IP address is 8.8.8.8. IP router ISIS, here also we have enabled the ISIS protocol. Then as you know, in router ISIS we have to define net address. So net address is 49.00000000000008. I am using 8 as a router number and then 00. This is my NAT address. Then IS label IS type label 2, log adjacency change all, metric style wide, and MPLS LDP auto config. We have enabled MPLS on all ISIS enabled interface. Then we have again two VRF here, one VRF for side 2 of customer A and one VRF for side 2 of customer B. So I am creating VRF A2 for side 1 of customer, side 2 of customer A, and I am creating VRF B2 for side 2 of customer B, right? For customer A side 2 VRF A2, for customer B side 2 VRF A2, and I am defining same RD value here, and same route target value also 100 ratio 100. Okay, for VRF B also you can see customer B is using route target value both 200 ratio 200 and RD value 2 ratio 2. After that, interface fast Ethernet 2/0, which is connected with router number 11. Here you can see router number 11. So this interface should be the member of VRF A2. So I have defined this interface in VRF A2, and then IP address. IP address between router 8 and router 11 is, I am using 81 network, and between router 8 and router 12 I am using 82 network. So here you can see IP address is 81.1.1.8. You can use any IP address, doesn't matter. Okay, so we have defined the interface in VRF, and we have defined the IP address. After that, interface fast Ethernet 3/0, which is connected to router number 12. IP address is 82.1.1.8 and 255.255.255.0, no shutdown. Then, as you know, we need to configure BGP. So router BGP 65001. Here I am using ISP, in ISP2 I am using BGP AS number 65001. After that, no BGP default IPv4 unicast, as you already know. The neighbor 6.6.6.6 remote AS 65001. Okay, so there is router 6 is route reflector in ISP2. So we will configure BGP neighborship between router 8 and router 6, and router 5 and router 6. So neighbor 6.6.6 remote AS this one, and neighbor 6.6.6 update source loopback 1, address family VPN v4, neighbor 6.6.6 activate. Then we are going to configure BGP for VRF. So address family IPv4 unicast VRF A2, and neighbor 81.1.1.11. This is the IP address of router 11 fast Ethernet 0/0. This interface IP address. So configuration is similar like previous video of edge router or PE router. So this is configuration of BGP for VRF. This is also configuration of BGP for VRF B2. This is configuration of router number 8. Let me copy the configuration of R8 here. What happened? R8 till here. Let me copy the command. Yes, and let me paste this command on router number 8. Config T. Okay, we don't have any error here. That means all command is correct. Now on router number 8 you can verify the configuration. So IP VRF, okay, and so MPLS interfaces. Okay, so MPLS is enabled on both interface. Then router number 7, on router number 7 we need to configure ISIS and IP only, and MPLS. We are not going to configure BGP on router number 7. So this is configuration of router 7, MPLS label range 700 to 799. IP configuration, IP between the network between router 5 and router 7 is 57.1.1.0. So IP address over here is 57.1.1.7, 255.255.255.0. IP router ISIS network point to point interface fast Ethernet 1/0, which is connected with router number 8. IP address is 78.1.1.7. IP router ISIS network point to point, and then ISIS configuration and MPLS configuration. Now let me copy the configuration of router 7 and let me paste it on R7 video. Okay, okay, done. Now we can verify. So ISIS neighbor, you can see router 8 is neighbor, and so MPLS LDP neighbor. So you can see 8.8.8 is LDP neighbor. Okay, now let me configure next router number 6. On router number 6, as you know, we are going to configure two BGP neighbor. Router 8 and router 5 is neighbor of router number 6, and both are route reflector client. So host name R6, MPLS label range 600 to 699. Then this is the IP configuration on interfaces. And ISIS configuration, we have one loopback 6.6.6 and router ISIS. This is router ISIS configuration, MPLS LDP auto config, and then BGP. So router BGP 65001, neighbor 8.8.8, remote AS 65001, neighbor 8.8.8 update source loopback 1, neighbor 5.5.5 remote AS same, and neighbor 5.5.5 update source loopback 1. And then address family VPN v4, neighbor 8.8.8 activate, neighbor 5.5.5 activate, neighbor 8.8.8 route reflector client, neighbor 5.5.5 route reflector client. Router 6 configuration is similar to the configuration of router 2. Router 7 configuration is similar to router number 3. Router 5 configuration will be similar like router number 4, and router 8 configuration is similar like router number 1. Now I am going to copy this configuration, router 6 configuration. Let me copy it and let me paste on R6. Here also I don't have any error. BGP neighborship, LDP neighborship, then BGP neighborship, and there is ISIS neighborship also. So ISIS neighbor, you can see router 8 is neighbor because we have not configured router number 5, and so BGP VPN v4 VPN v4 unicast all summary. So 5.5.5 is neighbor. This neighbor is idle now because we have not configured R5, and router 8 is the neighbor. Okay, fine. Now router number 5. On router number 5, router 5 configuration is similar like configuration of router 4. Here you can see host name and label range, and then IP address on this interface, fast Ethernet 1/0, which is connected with router number 6, is 56.1.1.5, and IP router ISIS network point to point interface fast Ethernet 2/0, again IP address is 57.1.1.5, and IP router ISIS network point to point. Then we need one loopback 5.5.5 and IP router ISIS. This is the ISIS configuration, and then we have enable MPLS. Okay, then here also I am going to create two VRF A2 and B2. You can configure different VRF as well, but I am configuring same VRF. But route target import should be same like whatever route target router 8 is exporting. Okay, in VRF A2. Fine. Then route target value. After that, fast Ethernet 0/0. On fast Ethernet 0/0, fast Ethernet 0/0 of router 5 is connected with router number 4. I need to run only no shut command, and then we will divide this interface into sub interface. Interface fast Ethernet 0/0.1, IP VRF A2, and encapsulation .1q, and IP address is 45.1.1.5. Okay, and then interface fast Ethernet 0/0.2, IP VRF B2, encapsulation .1q for VLAN 2, and then IP address. I am using same IP address on both interface. Okay, after that router BGP 65,000, no BGP default IPv4 unicast, neighbor 6.6.6, remote AS 65,000, neighborship between router 5 and router 6, and neighbor 6.6.6 update source loopback 1, address family VPN v4, neighbor 6.6.6 activate. Let me copy this part of configuration and let me paste on router number 6, router number 5, sorry, here it is. Okay, so let me paste this configuration on R5. Okay, configuration is fine. So ISIS neighbor, so router number 7 and router number 6 should be the ISIS neighbor. Let me check the host name on router number 7. Here host name I think is host name R6. Here let me correct it on router number 6. Host name is R6. That is fine. Fine. Maybe I have missed. I have not copied that command. Okay. So now on router number 5 we can check router 6 and router 7 is ISIS. Now guys, we will configure again customer edge router like router number 11 and router number 12. On router number 11 and router number 12 configuration is similar like router 9 and router number 10. So router number 11 you can see configuration is IP configuration first of all, then loopback. On loopback here I am running network 192.168.2.0/24. So on loopback IP address is 192.168.2.1. Then BGP 100 and neighbor 81.1.1.8 and remote AS 65001. And then network command, with the help of network command we have advertised this network in BGP. So let me copy this command and let me paste it on R11. After that soon BGP neighborship will come up between router 8 and router number 11. Yes, you can see here, and so IP BGP you can see 192.168.2.0 network is there. Fine. Now next configuration is router number 12. On router number 12 also configuration is same. I am going to copy the command and I am going to paste it on R12. For customer B we are running BGP 200. Okay, here also BGP neighborship will come up. So IP BGP. Okay, in BGP table this prefix is not best for now, but it will become best. Now you can see it is best. And both router 11 and router 12 will advertise network to router number 8. So on router number 8 we are going to verify it. So IP route, let's say VRF A2. So in A2 routing table you can see router 8 have received this network 192.168.2.0, and for VRF B2 it have received this network 172.16.2.0. okay, and we can check BGP table also. So BGP VPN v4 unicast all. So in BGP table also we are able to see this network 192.168.2.0 is injected in VRF A2, and this network is injected in VRF B2. This network is injected in A2 and this network is injected in B2. Okay, now router 8 will advertise this network information to router number 6. So let me take you to R6, and on R6 also we are going to check. So BGP VPN v4 unicast all. Here you can see this network is injected in BGP table of VRF A2, or you can say route RD value 1:1, and here RD value 2:2, or we can check BGP table like this also, RD value 1:1 and 2:2. So both prefixes are there in BGP table of router number 6. Router 6 will advertise it to router number 5. So let me check here BGP table. So BGP VPN v4 unicast all. Okay, so you can see in VRF A2 this network is injected 192.168.2.0, and in VRF B2 this network is injected 172.16.2.0. Now router 5 have the prefixes of customer A side 2 and customer B side 2, right? And router 4 have prefixes of customer A side 1 and customer B side 1. Okay, what is happening here? Let me make you understand again. See, router 1 have received this network to their neighbor, and router 1 have advertised this network to router number 4. Router 4, it will advertise VPN v4 prefix 1 ratio 1 ratio 192.168.1.0/24, this network, right? And after that 2 ratio 2 ratio 172.16.1.0/24. Router 1 will advertise this network to router number 4, to router number 4, to router number 4. Now router 4 have these two network, okay, and here we have router number 5, R5, and R5 have also received two network from their neighbor, one is 1 ratio 1 ratio 192.168.2.0/24, and one neighbor is one prefix is 2 ratio 172.16.2.0/24. Now we need to exchange these prefixes between router 1 and router 5, and router 5 have received this prefix to their neighbor, which neighbor? To their neighbor R8. R8 have received these two network from their neighbor. R8 have received normal prefix, normal 192.168.2.0/24, and this neighbor have, means router number 12 have advertised 172.16.2.0/24, right? Okay. Router 8 have advertised this VPN v4 prefix to router number 4, to router number 5. Let me show you here. Now we need to exchange these two prefix between router 4 and router number 5. Router 4 have these two network and router 5 have these two network, right? We are going to, here again we have two sub interface between router 4 and router 5, two sub interface. We have two sub interface between router 4 and router number 5. This is for VRF. Let's say here VRF A1. This is a member of VRF B1. This is A2 and this is B2. We have VRF over here, right? So now we need to exchange these two prefixes, between router 4 and router number 5. So guys, like between customer edge router and provider edge router, how we are exchanging prefixes? Here we have EBGP neighborship, and router 9 is advertising this IPv4 prefix to router number 1. In the same way, router 4 is going to advertise this network, not this network, IPv4 prefix, this prefix to this VRF if we will have BGP neighborship. So we are going to configure one BGP neighborship over here and one BGP neighborship over here, right? So that these two routers can exchange IPv4 prefix, not VPN v4 prefix, IPv4 prefix. So what I am going to do, on router number 4 and router number 5, I am going to configure BGP. Here you can see router 4 is connected with fast Ethernet 2/0.1 and fast Ethernet 0/0.1 is connected with router number 5. This is how router 4 and router 5 are connected with each other. Router 4 and router 5 are connected with each other. So see how I will configure BGP. On router number 4, I am going to say router BGP 65,000, address family IPv4 unicast VRF A1. For VRF A1, I am going to say neighbor 45.1.1.5 remote AS 65,001. That's it. And then address family IPv4 unicast VRF B1 and neighbor 45.1.1.5. remote AS 65,000. That's it. What will happen after running this command on router number 4 and router number 5? First of all, let me run this command on router number 4. Router number 4. Let me run this command. Done. And on router number 5 also I am going to run this command. Copy and paste on router number 5. Two BGP neighborship will come up between router 4 and router number 5. Just wait. Two BGP neighborship will come up. One on fast Ethernet 0/0.1 and one for fast Ethernet 0/0.2. You can see neighbor 45.1.1.4 VPN VRF B2 and 45.1.1.4 same IP address VPN VRF A2. Okay, and now if you will check BGP table, so BGP VPN v4 unicast all, you can see it have received this prefix 192.168.1.0/24 from their which neighbor 45.1.1.4 from their neighbor 45.1.1.4. Why it have advertised this network? Router 4 have advertised this network to their neighbor, because see on router number 4 or on any router means router 5 is also will also advertise this network and this network to router number 4 to their eBGP neighbor. Okay, see on router number 4, so BGP VPN v4 unicast all. Here also we have received this network 192.168.2.0 and next hop is 45.1.1.5. Whenever router 4 need to forward traffic to this network, right, it will forward traffic to 45.1.1.5, right, 45.1.1.5 means to router number 5. Okay, and so okay, one more thing I want to discuss here is, okay, when we will discuss next option, you will automatically understand these things, but now let me discuss the packet flow, or let me check the end-to-end reachability, that side 1 of customer A is able to ping side 2 of customer B or not. For that, let me take you to router number 9, and on router number 9 I am going to check first routing table, so IP route. So in the routing table you can see it have received this network side 2 network 192.168.2.0/24, and router number 10 will also have side 2 network, so IP route you can see 172.16.2.0/24, and if network is available they can communicate with each other. On router number 11 also we can check, so IP route you can see it have received this network 1.0, right, and router number 12, so IP route this network 172.168.16.1.0/24. and now when router 9 will ping, let me first check ping is working or not. 192.168.2.1 and source is 192.168.1.1, so ping is working, right. In the same way router number 10 also, let me check connectivity, ping 172.16.2.1 and source is 172.16.2.1. So here also ping is working, and we can trace route as well. Trace route 172.16.2.1 and source 172.16.1.1 and say numeric. So router 10 is forwarding traffic to router number 1 10.1.1.1. router 1 is forwarding traffic to router number 2 to route reflector, and router 2 is forwarding traffic to router number 4, this router 4 is forwarding traffic to this router number 5. Router 5 is forwarding traffic to router number 6. Router 6 is forwarding traffic to router number 8, and router 8 is finally forwarding traffic to router number 12. How ping is working? See, when router number 9 will ping this IP address, ping 192.168.2.1 and source is 192.168.1.1. It will, and device will generate a ICMP traffic, and device will generate one ICMP traffic. In that ICMP traffic, source will be, let me show you. When it will ping, source will be 192.168.1.1 and destination will be 192.168.2.1, right? After that, router 9 is going to check their routing table. Router 9 will check their routing table. In their routing table of router number 9, so IP route, one route is available for this network 192.168.2.0, and this network is reachable via 19.1.1.1, means router number 1. So it will forward the traffic to router number 1. When router 1 will receive the traffic, it will receive, router 1 will receive traffic on fast Ethernet 2/0, on fast Ethernet 2/0. So it will check fast Ethernet 2/0 is member of VRF A1. It will check routing table of VRF A1. So IP route VRF A1. In VRF A1 routing table, there is one network available 192.168.2.0/24, reachable via 4.4.4.4. This network is reachable via 4.4.4.4, and 4.4.4 is available in global routing table, not in this VRF routing table. So it will check what SAP table for to forward traffic to 4.4.4. So IP SAP 4.4.4.4 and slash, let's say 32. It will came to know that there is two path available, and let's say we want to forward all traffic from router number 1 to router number 4 via router number 3. So what we can do, we can change the cost of fast Ethernet 1/0. So let me do it. Let me change the cost on fast Ethernet 1/0. IP OSPF cost, let's say 100, right? And now if it will check SAP table, so IP SAP, you can see in SAP table there is two path available, reachable via 12.1.1.2 or reachable via 13.1.1.3, and this is labeled packet. Router 1 will came to know that this is labeled packet, and now there is only one path via router number 3, right? And label is 304, right? It is labeled packet, and there is one more label with prefix. When router 1 will receive VPN v4 prefix, so BGP VPN v4 unicast all summary and 192.168.2.0 and 255.255.255.0. when it will receive this VPN, sorry, not summary here, this VPN v4 prefix, it will have one label. Label number is 405. So it will put one label over here, inner label. Router 1 will put one inner label, that will be 405, and one outer label for 4.4.4.4, that is available in SAP table 304. It will add this label 304, and after that, here you can see exit interface is fast Ethernet 0/0. Next hop is 13.1.1.3. It will forward the traffic to router number 3. When router 3 will receive this traffic, router 3 will check their forwarding table, MPLS forwarding table, because router 3 is receiving labeled packet. So router 3 is going to check MPLS forwarding table. So MPLS forwarding table. In MPLS forwarding table, it will find local label of 304. So 304 is here, 304 local label. Whenever 300 it will receive traffic with label 304, it will pop the label. Outgoing label is no label. It will pop the label and it will forward the traffic to 4.4.4, right? And 4.4.4 is reachable from this interface fast Ethernet 1/0. Next hop is 34.1.1.4. It will remove outer label, means 304, and after that it will forward this traffic to router number 4. When router 4 will receive this traffic, router 4 will check what? Router will receive it on fast Ethernet 0/0, and this is labeled packet. And what is the label? Label is 405. So it is again going to router 4 is again going to check their MPLS forwarding table. So MPLS forwarding table, and in MPLS forwarding table it will find local level 405. So local level 405 is here. For this label we are going to pop the label no label, and 192.168.2.0/24 network is reachable via fast ethernet 2/0.1, and next hop is 45.1.1.5. it will forward without labeled packet from fast ethernet 2/0.1. next hop is 45.1.1.5. it will remove the label. Router 4 will remove the label, and it will forward the traffic from fast ethernet 2/0. Now router 5 will receive this traffic on which interface? It will forward the traffic to router number 5. Router 5 will receive this traffic on fast ethernet 0/0.1. Fast ethernet 0/0.1, and fast ethernet 0/0.1 is a member of VRF A2, so it will check routing table of so IP route VRF A2 in VR. So sorry, on router number 5, so IP route VRF A2. In A2 routing table, yes, there is one network available 192.168.2.0/24, that is fine, and reachable via 8.8.8. reachable via 8.8.8.8, and again 8.8.8 is available in global, so it will check what? SAP table. And before that there will be one label with this prefix in VPN v4 prefix. So BGP VPN v4 unicast all and 192.168.2.0 here label is 804. so inner label will become 804 over here, 804, and outer label will be, let me write here, let me take it here, and outer label will be so IP SAF 8.8.8.8/32. so again we have two paths. Let's say it is performing actually load balancing, but let's say we have only one path via 57.1.1.7, 57.1.1.7, 57.1.1.7. so it will use this label, let's say 700. okay, so it will add outer label 700, and then it will forward the traffic from which interface? Fast Ethernet 2/0. next up is 57.1.1.7. it will forward the traffic to router number 7. router 7 will receive labeled packet, so router 7 will check directly MPLS forwarding table. so MPLS forwarding table, local level is 700. okay, so local level is 700. for local level 700 we are going to pop the level and forward the traffic to 8.8.8 from exit interfaces fast ethernet 1/0. next up is 78.1.1.8. it will pop the label, means remove the upper label, and it will forward the traffic to router number 8. it will forward the traffic to router number 8. when router 8 will receive it, what router 8 will do? Router 8 will receive this traffic on fast ethernet 0/0, and what is the label? 400, 804. so router 1 is also going to check their forwarding table, so MPLS forwarding table. so in forwarding table you can see for 804 we have popped the label, and prefix 192.168.2.0/24 is reachable via fast ethernet 2/0. next hop is 81.1.1.11. so 81.1.1.11. so router 8 will pop the label, remove the label from here, and it will forward the traffic to router number 11, and in the same way router number 11 will generate reply. This is how these end users are going to communicate with each other, and in the same way customer B also communicate with side 1 and side 2. okay, so guys, in this video we had discussed inter-autonomous MPLS VPN by using option A method. In next video, option A is called back-to-back VRF. In next video, we will see option B method. If you have learned something from this video, guys, please hit on like button. If you have not subscribed the channel, please subscribe the channel. We will meet soon in next video. Till then, stay safe. Bye bye. See you in next